Hello everybody, welcome to this webinar. So we are going to start the session. So I hope that everybody can hear me very well. So before I begin, I'm going to present myself. I'm Dr. Dan, the Central Africa Manager working right now in Midas HQ in South Korea. So I'm really glad that you are connected, and I wish you to follow the webinar from the beginning till the end because it's really interesting. We are going to start with a brief presentation of the agenda and then a brief presentation of our company and what we do in Midas IT. Then we are going to start to explain about the design, optimization of reinforced concrete culvert bridge and the various loading condition. I hope that everybody can see the screen, so I can start the session. The content in this webinar is divided in 6 parts. So the first part, we are going to introduce our subject, and then we are going to model the culvert bridge, and then we are going to apply various loading conditions upon the culvert bridge. And the fourth point is about the analysis and design optimization. Then we are going to interpret the result, and then we are going to learn how to generate the report. The company of Midas IT is there to serve you and to make any engineer all over the world happy using the tool we develop here in our company. So for you to know very well the product we develop to make you happy, you need to be trained by experts here in Midas IT. So we do trainings all over the world. As you can watch the picture on the screen, we can do training even in Africa, in India, in Europe, in the USA. So whenever you have any technical problem or you want to learn more about our product, you are welcome to send me a text message or an email so we can collaborate easily. When someone wants to learn more about our software, for example, Midas Civil, you need to practice. And when you are practicing, you are going to gain new knowledge and you are going to improve your skills when you are modeling the structures. And the product of Midas Civil is based on a bridge design. So that software can model every kind of bridge, from the conventional to the very complex bridge, and Midas Civil can handle. So for today, we are going to learn about the culvert bridge, which is the simplest among the bridge, but a lot of people, they're still doing this culvert bridge project, and they still ask a lot of questions about the modeling and the design of this structure, which is really important. So this structure can help us to control the stream flow and to regulate the traffic. I'm going to explain about the culvert design process. So we are going to run through this process in order to make the design of the complete structure. The first step to do is to establish the design condition, and the second one is about the pre-dimension. We need to predefine the section, and then we need to define the boundary condition of our structure, and then we are going to analyze the structure. After analysis, then we can design the structure and generate some drawings that can help us in the construction of the structure. So about the design condition, okay, we have to determine the parameters that we are going to use in the design. So first of all, we need to do the ground investigation, and then we have to select the materials we are going to use and to specify the material properties. After that, we need to analyze also what kind of load will be applied on the culvert. So in our case, we are going to analyze different pressure applied on the culvert. So we have soil pressure, groundwater pressure, live load, as you know, the moving load, and then seismic load. And I know that you know very well that seismic loading is not easy and it needs to be treated separately so we can understand very well the flow of the design. So we are not going to mix this load condition with a seismic load. So I'm going to prepare another session about seismic loading applied on the culvert bridge. The structural shape we are going to use it one cell culvert box. In the inner diameter of this culvert, it measured 2.2 meter in X direction and 2.2 in Y direction. The unit weight of the material we are going to use is for the reinforced concrete, we used 24.5 kilonewton per cubic meter. And if you want to use the mortar, you can specify the unit weight for the mortar, and it's 21 kilonewton per cubic meter. And then the strength of the material for the concrete, we have 24 MPa, and the Young modulus of concrete, it's 27 MPa. And for the yield strength of the steel is 400 MPa. And lastly, we have the modulus of elasticity of steel. It's 200,000 MPa. So other soil property for the culvert we are going to analyze, we have the wet soil unit weight. It's 19 kilonewton per cubic meter. For the submerged soil unit weight, we have 10, and then we have the internal friction of soil, we have 30 degree, and the coefficient of earth pressure at rest, we took it as 0.5. After using the internal friction soil, you can replace it with its value here in sin phi, then you will get 0.5. Then the underground water level is took at -1 meter, and the underground water unit weight is 10 kilonewton per cubic meter. So for the live load or the moving load on the ground surface, we use this standard vehicle, DB24, and the value is this one. So in the coming slide, I'm going to explain how to calculate this value so you can understand very well how to get it easily. And the other pressure, we are going to learn how to calculate them also. So for the section we are going to use, it's a 2-dimensional section. As you know that for the culvert, even if you have if you analyze even 2D, you can analyze, you can get similar results even for 3D analysis. So for the section we are going to use, in this direction, we are going to take 1 meter, and then the upper slab, as you can see here, it has 0.4 meter of thickness, the thickness of the upper slab. And then the wall also have a 0.4 meter, and the lowest slab thickness is the same for all. The thickness is constant for all the structure. The other verification we have to do, it's about the buoyancy, because we have the underground water. So we need to verify the condition, the safety factor and this safety factor can tell us if the section we select is it's good or not. Even if before the design in the software you need to select a section that you need to predefine the section that you are going to use for the analysis. So checking about the buoyancy, it's really important, and because it's going to help you to perform the design. So after performing the design, you are not going to repeat a lot of stuff if the section didn't pass. So first of all, you need to check about the buoyancy, which it's an upward force that can push up the structure because of water. This is the condition we are going to use when we have the underground water and when we don't have underground water. So all of these load conditions, we are going to use them in the analysis. When you calculate the resisting forces over the buoyancy, you need to have the value that is higher than 1.2. So for the resisting force of the buoyancy, we have the self-weight of the structure, we have the vertical pressure, and then we have the groundwater pressure. So these three loads have to balance well with the buoyancy that will be created due to the underground water. So these are formulas that we are going to use to calculate different loads. So we have the vertical earth pressure and its formula, the horizontal earth pressure. The first case we are going to analyze, it's about when we don't have the underground water. And the second case we are going to consider the underground water. So when we have the underground water, this is the vertical earth pressure when we have the underground water. But this one is the vertical pressure when we don't have the underground water. And for the horizontal earth pressure, we use the coefficient of earth pressure times the unit weight of the soil multiplied by the height. So this is the formula of the coefficient of earth pressure. So with underground water, the horizontal earth pressure can be calculated using this formula. To calculate the self-weight, it's really easy, and I hope that all of you have learned how to calculate the self-weight of the structure. For the upper slab, because the width of our section is 3, so we are going to use 3 times the thickness of the slab times the unit weight of concrete, and then you get this value here. So I'm not going to explain deep this value because you know all of them, so we are going to use them in the software very quickly. And about the haunches, we have four corners of haunches. So the dimension, as I show you on the screen, you have to multiply by 4, and then the unit weight of the concrete. This is the way you can calculate the load acting upon the upper slab, because the section of the, okay, let me explain a little bit about the section. Even if it's a 2D, but we consider 1 meter in this direction here, that's the presence of this 1 times the unit weight of the wet soil times the width of the structure, then it's going to give you this value here. And similarly, you can get the load when we have the for the submerged soil, and then the self-weight of the underground water also can be calculated similarly. So these are the other formula when we consider water pressure in the ground. So for the water pressure, these are the formula you can use to get the the value of the load. So the other important thing to specify here is about how to make the model. So I know that a lot of people there, they do know that in Midas Civil we have 3 different ways to model the structure, but in this webinar we are going to use the node element method to model the culvert, to model the structure. And in order to model the structure, we need to model it at the centroid of the structure as specified here. So we don't take all the thickness of the structure, but we specify the lines at the centroid. That's why this line, when you make the plane to make the model, you have to remember that these lines are at the centroid of the structure. So you can ask me, so what about the load that can be applied here on the structure in this corner? So about this load, don't worry about that because it doesn't influence too much the structure when you use the line at the centroid. So you don't need to worry about the load that can be applied in this area. So when you calculate the load, don't forget this location when you are calculating the pressures. So when you are calculating the horizontal pressure, for example, the height should start here at the centroid up to the top of the structure when you calculate the load applying here. And for this one also, you don't need to start here, but from the center line where we have the centroid, and then you go up to the top. I hope we are going to do that in the software very soon. So I just show you how I calculated the different load we are going to use in our demonstration. So this is about the earth pressure, the vertical one, and the earth pressure, the minimum, and this one is the maximum. So as you can see, this distance here is 2.5 meter, but to reach at the centroid, it's 0.2. This distance is 0.2 meter. So you are going to add this distance here plus 0.2, which is going to give you 2.7 times the unit weight of the soil times 0.5. And this is the value of the pressure, the horizontal earth pressure. This is the coefficient of earth pressure, as I explained before. So I'm going to go a little bit faster so we can start using the software, because I know a lot of people, they are waiting for the demonstration. So I just showed the result I got when I calculated the vertical earth pressure and the horizontal earth pressure. And this is the case where we consider the underground water. So also using the previous formula I showed you, you can get this value easily. So for the case of the water pressure also, as I showed you the formula, you can use them to get this value, but you need to respect the center line of the structure where we are going to apply the loading. That's really more important. You don't need to forget that. So about the live load or moving load, we are going to use on this vehicle, this truck, and this truck is based on the Korean Highway Bridge design code. But don't worry about this code, because the calculation of live load or moving load, they are similar for different code. It's just the calculation to get the value we are going to use in the software. But in the software for the design, we are going to use Eurocode. So don't be upset about this code of Korean. So as you know that we have to consider the maximum load of the truck. So this value here, they are given, but W is specified by this value here, 24 ton. That's the meaning of this value. W, the value of W is 240 kilonewton. So you have to multiply this value by 0.4 to get the maximum load that can be produced on this wheel, under this wheel. And this value, we are going to use it to calculate the live load or the moving load applied on the culvert. So as the load of the truck doesn't go directly vertical when it passes over the structure, the distribution of the load is follow 45 degree. That's how the distribution of the load happen when a truck is passing over a structure or over the soil. And that distribution, in different code, they can define the value of H that we have to apply the live load is defined by this value here. H, this value of H, the height where we have the structure, and then the contact surface here is defined by 0.2. So this value, you can check them in different code to define this value. The width on which the moving load can be applied is defined by 0.2 plus 2h. So in this is the width where the load, the influence of the load can be localized when we are calculating the laving load. Based on the code, the minimum value we have to apply for the live load is 10 kilonewton. 10 kilonewton per meter square. And this value was found based on an experiment. It's not by using this value. No, this just the definition in the code based on experiments that they define this value here. So there are different cases that we need to know when we are designing the live load. So if the structure is far away from the ground surface, the influence of the live load can be neglected. So based on the H, the height of the ground, there are some value. If H is greater than 3, so the influence of the truck will be neglected. But for the value that are in this interval, then you need to consider the influence of the live load on your structure. So for our case, we have this one. When the influence of the live load cover all the structure, and in this case we have only the one portion that is covered by the area where we have the influence of the live load. So these are formulas that I will not explain them. You can use the code to calculate this value, but the value we calculated previously, it's this value is 96. And then I, it's the impact factor. B is the width of the structure. And then W is the width of the live load, the width of the live load distribution. So this W2 is the one that I just explained, that it's 0.2 plus 2h. This is the value of the width of live load distribution. So in our case, we are going to use the formula of this first case. And after using that formula, we found that the live load is 13.5 kilonewton per meter square. And when you want to check about the value of the impact factor, you can check the code, and they give the impact factor even in the tabulation form, so you can check them very well. So when we are in this interval, based on the height, the distance from the top surface up to the upper slab, that distance, when it is in this interval, so the impact factor, it's about 30%. And when it's between 1 and 2, we have 20%, and in between 2 and 3, it's 10%. And then if H is greater than 3, then the live load doesn't have any influence. So we can continue. These are the value of the live load we just calculated. The live load acting in the horizontal direction, it's calculated as the coefficient of earth pressure times the minimum value of the live load based on the code. So this is the value that we calculate, because K0 is 0.5 times 10, it's 5. So when we are doing the design, we are going to use the load combination, and the load combination we are going to use in design, it's like in real design. So this example is going to help you very much when you are doing the design of culvert. And these are the factors based on the ultimate strength design, and this one is for the serviceability. So we are going to use them in Midas Civil when we are doing the demonstration. For the boundary condition, we used the compression only spring. So this spring, you need to understand it very well so you can understand. If you use it in a wrong way, you will get error. You need to understand how it functions, then you will apply the load very well. So if I can explain it in brief, so when you have this compression only spring, the load is applied here on the top, but in this part, if you apply the load in this direction, you will get wrong answer. So you need to be careful. For example, when you have the pressure, the vertical pressure in this direction, for example, you have 45, the value we have for the vertical earth pressure, and for the buoyancy we get, it's 45 kilonewton per meter square. So when you have these two values, you have 15, and then here you have 45. If you subtract this value, you are going to have minus 30. So when you have the negative value like that, it means that this load will act from these parts of the spring. So you need to make sure that the load is applied on the top of this spring when you're applying the load. So this, to avoid this case, you have to use the load combination as I showed you before, especially in this case, USD 02, you have that problem about the water pressure. So I'm going to explain it when we are running the software so you can understand very well. So to calculate the stiffness of the spring, you can go down in the code, because you need to do experiment to get real value of the ground you have. So I will not go deep in the explanation of that. But the unit of the subgrade reaction, to get the stiffness, you need first to have the value of the subgrade reaction. And the subgrade reaction unit is kilonewton per cubic meter. So after getting this value of subgrade reaction, then you can multiply this value by the area to get the stiffness of this spring. This is the formula used after getting this value by experiment, because there are some value here you can use the experiment to get those values. So I will not go deep in explanation, because this value is determined by experiment. So you can ask question to the geotechnical engineer, so you can get this subgrade reaction. After getting this subgrade reaction, then you can calculate the stiffness of this spring here. So to calculate the stiffness after getting the subgrade reaction, it's really easy. Okay, this subgrade reaction multiplied by the half distance between these two nodes to get the stiffness of this for the first node here, the first spring. So in the next table, I can explain it. So when you are applying the boundary condition on different node here, you need to make a plan about the node you are going to use in the design. So based on the result you want to get, you can specify the number of nodes you are going to use for the boundary condition. So I know that a lot of people there studied the finite element analysis. So you need to specify the distance, a proper distance of the spring in order to have a good simulation result. Because this, if someone space the spring widely like this, the result can't be the same as someone who place a lot of spring on this side of the structure. So you need to use those rules you learn in finite element analysis to specify the distance you are going to use between the spring for the boundary condition to simulate the soil. So after calculation for node number 1 and node 13, we have this stiffness for these two nodes, and for node number 2 and 12 we have this value. For 3 and 11 this value, then node 5 through 9 we have this value for the stiffness. So I said that you need to multiply the subgrade reaction times the area. So here the area we have, let me show that area. It's in this direction. So you are going to use this. This is the first node, and the other node is here. This is the half distance between these two nodes. You are going to take this distance times the distance in this direction, and this distance is 1 meter. Is the section we took. The section we are going to use in the design, it's 1 meter in this direction. So here you need to multiply by 1 meter. So as you can see here, you have kilonewton per meter per cubic meter times the first meter here for the width times the 1 meter in that direction just explained. Then you will have the unit for the stiffness, kilonewton per meter. So these values are stiffness of the spring. This value, we are going to use them in the modeling. We are going to open the software and explain all the steps we have defined there. So this is the window of our software, Midas Civil. To open the new project, you need to click on this icon here on the new project, or you can click on this icon here, and then you can find a new project. Or if you have an existing project, you can click here. So I'm going to use this icon for the new project. Okay, I will open the new session, the new project. Okay, this is the new project that I have opened. So to begin the a simulation, we have to define first the unit we are going to use. You can go to tool menu and use the unit system. You can select meter, kilonewton, and then you are going to hit on OK. Or you can use the status bar here. You can select the unit here also very easily, because our software is really well designed, and it's a user-friendly software, so you can use it very easily, and you can modify the units whenever you want. So as I specified before, we are going to use node element method to model the culvert. First of all, we can define the material we are going to use, then we can go to the geometrical modeling. So to specify the material, you need to go to property and then material property. Then you can define the material section and the thickness. So we are going to start by material. Then we are going to click on add, and we have different material. We are going to use concrete, and let's select the design that you like. It the code you like, it's a BS. A lot of people, they like BS in Africa, so I select the concrete based on the BS standard. So we can select the compressive strength of the concrete, and then we can specify the name of concrete at C25, and then we click OK. So because we have only one material in our project, so that's enough for the material. We can define also the section. Click on add, and the shape of the section, as I explained before, it's a solid rectangle. I'm not going to use the DP, but I'm going to use the user defined shape. So for the height, it's 0.4. When you are inputting the data, make sure about the units you are using, because you can use different unit system, and that will give you a wrong answer at the end. So this is the section we are going to use for the low slab. The low slab shape section is 0.4 and 1. Then I'm going to click on apply. Then the other section, it's about the wall. Then I'm going to click on apply. And the last section, they have the similar size, so I didn't change the value. And for the upper slab, we have the same section, and then I click on OK. So we have 3 sections that we are going to use in the model. For the lower slab, this one I can modify the name. It's lower. I'm sorry for the mistake. Lower slab, and then wall, and then upper slab. Then I can close. So after that, we can create the node. To create the node, we can go here to create node, and then we can specify the reference node. We can create it at 0.0.0. I can click on apply, and then you can realize that there is a node created here at the reference, the origin. So there are different ways you can create other nodes here. In Midas Civil, you can extrude this node to a line, because we are going to use a 2D simulation, so we can extrude that node to a line, so we can make the beam element based on using the extrude function we have in Midas Civil. So for that, as you can see, that we are going to extrude element, but we are going to use node to line element. There are different ways you can extrude line element to planar element, and planar element to solid element. But in our case, we are going to use node to line element. And we are going to use the element type we are going to use, it's beam. And the material we just created is concrete C25. And the section, it's we are going to use for the lower slab section. So if you want to modify the section, you can hit on the 3-point here and modify the section we just defined. But as we don't need to modify, you can continue easily. You can define even different distance to extrude this point here. So I'm going to use the relative distance that I prepared here, and they are an equal distance. So I can paste here the different distance that I used for my, when I show you the spring, those distance between the spring, those distance is the distance that I'm using, and I cap and paste those distance here from Excel sheet. So you can prepare those distance in Excel sheet and copy and paste them here in this area, and then you have to select the reference node. After selecting the node, then you can hit on apply. But before hitting on apply, you need to specify the direction of the extrude function. So we are going to extrude in X direction, in this direction. So I have to hit on apply. So that's the node and elements that are generated. You can see them very well. The node that we just created, we have 1 up to 13 node. So to create the wall, this is the lowest slab. So to create the wall, I'm going to use the same, because we have the square shape box culvert. I'm going to select these 2 nodes here, node number 1 and node 13. Then I'm going to extrude them using the distance that I specified here. And then I have to change the section, even if they're same, but we can change the section to wall. And then because the material is same, we leave it in that way, and then we click on apply. Before clicking on apply, you can select the direction. The direction we are going to use is Z direction, this Z direction here, and then select the node, and then we are going to click on apply. Then you can check the wall, the created wall like this. It's really easy to create the box using this extrude function here. And for the upper slab, we have to select this node here, and the direction of the extrusion, it's X. Then we are going to click on apply. Then this is the they are telling us to save the, we can save the file. So this is the culvert box. You can watch it like that. So if you want to see it in a different colors, you can change the color as you want in the display view. So we can still have that same color. We don't need to change it. It's not that important. So this is the geometrical shape that we have for the culvert. The next step, we need to define the loading condition. For the loading condition, before reaching to the loading condition, you can check the nodal axis here. Not nodal axis, but the element axis, so we can see if they are properly apart here. So if you can check this axis here, you can realize that we have Z in this direction here, and we have Z upward like this one. For the upper slab and the left wall, Z is in the direction that we want to get the result. But for the left wall and down the lower slab here, Z direction is not good when we are going to apply the load, the pressure that we are going to apply on this culvert. So you need to be careful about applying the load, the pressure. You need to change the direction of Z when you are applying the load. So to change that direction, to change the direction of Z, you need to select first the wall, this wall, and then this. After selecting this left wall and this lower slab, then you can go to to node element and then change parameters. And in change parameter, you are going to change the element's local axis, and the element type is frame. So we are going to rotate the angle at 180 degrees. Then we already select the wall and the lowest slab. Then we hit on apply. Then you realize that the Z direction is in the proper direction when we apply the pressure on the structure. So after changing the element's local axis, then we can define the load that we are going to apply on the structure. So for the load, we need to define first the cases we are going to use. First of all, we are going to have the dead load, and we can select user define, and then we click on OK. The second load is going to be live load vertical in vertical direction, and it's select a user define load. And the other live load is in horizontal direction, and then I hit on add. The other load we have, it's the earth pressure in a vertical direction, and the earth pressure in horizontal direction. We have also the earth pressure in vertical direction, but with the underground water. The vertical pressure, the earth pressure in horizontal direction with the underground water. Lastly, we have the water pressure in vertical direction, and then the water pressure in horizontal direction. And we have nine cases of the load, or static load. Then we can close this one. After defining the load cases, then we can apply the loads that I showed you before in the PPT. So we can start by defining the self weight. The self weight, it's calculated automatically in the software. So we can choose, we can hit here, we can write -1 in Z direction. Then we can click add. That's how we define the self weight for the whole structure in Midas Civil. We can also apply the live load in a vertical direction. I don't know if you remember the picture, but as I have the value, I'm going to show you how to apply it. Let me hide the local axis first, so you can see very well how to apply the load. So for the live load, we are going to use this line element here, and we are going to input first the live load in vertical direction. In vertical direction, the value was 13.5, and the load is uniform. It's uniform load. We are going to use the local Z axis as specified for the element local axis. So we are going to select the direction of local axis. Make sure you don't miss this point, is really important. Selecting the axis because of the pressure, the different pressures we are going to apply on the structure. So after selecting that, you need to specify the value of the live load. I told you that we have 13.538. You need to check also the units, because the units are also important. So minus, it means that the load is downward. Then to apply that value, you need to specify the node, the first node and the end node of where you are going to apply this amount. So you need to click in this box when node for loading line. So you need to click here and select the node. You click on the first node and the last node, the load we have to apply. To check the value, you need to go here to the display and then click on node, not node but load, and then you can specify beam load and then click apply. And then you should select also a load value to check the value. So you can see that this is the value we are using. So we can continue applying the load. I'm going to go a little bit faster because we still have only about 30 minutes. So this is the vertical value for this one. So we need to apply also the horizontal load. For the horizontal load, we need to select LLH. It's a uniform load, and the value it's -5, and the local Z direction, you need to check it and then click on the node that we are going to use. We have to click on this load and this one. And then here also we have the value for that. Like that, we can apply the live load in the horizontal direction. We can continue with the earth pressure in vertical direction. Its value it's -34. So we need to click on this node here. We need to place the cursor in this area first and check the local Z direction, and then we click here. Oh, I have to select the node. Okay, we have selected the load case, and then we specify it's a unit load, and then the value of the node is 34. And then we need to select the load. We need to click here and then click on the node we are going to use. Okay, let me uncheck the value so you can see the load very well. Let me check the load and value so it can be clear but what we are applying. So that's the earth pressure vertical. So we need to select the earth pressure in horizontal direction, but this one it's not a uniform load, but it's a trapezoidal load. So we need to specify the load is a trapezoidal load. We need to go to local Z direction and specify this value of the pressure. It's 31 -31, I'm sorry, and minus 18. After specifying those values, then you can select the load. You can start where you have the highest value. Click here and here. Then the load is going to apply like that, and then you click here and here for the second load. This is the distribution of the earth pressure in horizontal direction. So we need also to go to the earth pressure in vertical direction, considering the underground water. So the value for this one, it's a vertical. Okay, it's vertical. The vertical value for this, it's this one I made interchange the value of this load here. I'm sorry. For this one, we have. Let me repeat this one because we make a mistake about the earth pressure in vertical direction. Earth pressure in vertical direction, we have it's based on the calculation we did in the presentation. I just interchange the value of these two load cases. So I'm going to modify it because it's easy to modify the load application here. So I can select EPV as the earth pressure in vertical direction, and the load is a uniform load. So I can change the local Z direction, and then I specify the value. The value is -47.5. Then instead of add, we need to say replace. So when we are going to replace the previous load because it was applied wrongly, we didn't apply it very well. So after doing this, you need to specify the node. Then we click on these two nodes here. Okay, that's good. And then we need to change also for the horizontal. For the horizontal, we have the trapezoidal load. Then we need to hit here 1, and then we put the value of the load starting by the big value. But it depends on where you're going to start the big value or the small value. It depends on the node you are going to click for the first time. Is minus 25.65. Then you click here, then select here and here for the trapezoid. Okay, this mistake this is a mistake. We didn't change the global axis to local Z axis. That's why it's applied in this direction of the global Z direction. So we need also to change that by selecting replace. Replace is selected, so we need to change, or we can go back by clicking on this icon, going back, or you can replace it in this way also. It's possible. Click here and here, so it's going to change the value. So when you have a lot of loads, you need to be careful, because if you don't be careful, you are going to make a wrong design at the end. So for this case, we have also to use replace. Okay, replace instead of add. Then we are going to start by the uniform load. The direction, we need to select local. We put the value minus 34, and the direction of this is vertical. So I'm going to go to the top, applying for the vertical one, and we need also to put the horizontal one. For the horizontal, we need to change the load type to trapezoidal load, local Z direction, and then here we put 1, and then here minus 31 and minus 18. Then I hit here the first load and then second, then first load and then second load here. That's the case for this one. So we can go to the last, water pressure in the vertical direction. The water pressure in the vertical direction, it's a uniform load acting in the local Z direction, and the value is minus 15. And we need to select the node of this one by clicking on the top slab here and here. And the value for the horizontal water pressure, we need to select the trapezoidal load here. We change the direction to local Z, and then we input the value. This is 1. The first value is minus 43, minus 17, and then we select the node, and then we click on this area, this node, and this one, and then this node and this one. So this is how we define the load. So after defining the load, you can check if the load are applied very well. You can go to the work tree and check the different load that we defined. The first load is this one. You go to the work tree and you can right click on the load and click display. So the first one is true. For the horizontal, it's minus 5, that's true. Then for the earth pressure in vertical direction, we have 47, and in the horizontal direction we have this is one we need to change this area. It's not good. This one should be 50, and here we have 25.6. So we need to modify here by going to line, and we have to select the EPH it's a trapezoid load, but we need to select a replace, and the local Z direction, we need to put here 1, and then minus 50, 35, and then minus 25, 65. Then we need to select the node here and here. But that's the real value for that. So we can go again to the tree. Can close this window, go to the tree to check the value of EPH. Okay, these are the value that they are true. And then we can check EPV VW. Okay, that's the real value. And then the other one for horizontal direction. Okay, and the last one for the water pressure. The water pressure in vertical direction. Okay, we forgot one load here for the buoyancy. We need to add it. So we go to load line, and then we select water pressure vertical. We need to add, we don't need to replace, and it's a uniform load. So when we have a lot of loading condition, yeah, we need to be very careful. So the design is really simple. It's going to take less than 5 minutes. So don't worry about this step. This step is most important. So I'm going to do it carefully because there are numbers, a lot of numbers. So try to understand. This one we have to apply the buoyancy. So we need to select the local Z. We need to add the load, and then put here 101. The value is minus 40, 45. After putting the value, then we can select the node where we are going to apply it, here and here. Yes, that's the load applied here. That's we forgot. So we can go again to the work tree, then we can check the value, display. Okay, and then the last one in horizontal direction. Okay, that's all the load condition we define very well, and we need to save the file like that. The other one, it's about the boundary condition. The boundary condition has told you that it's a spring, and the value of the spring I showed you. So we are going to use the compression only spring. So we go to boundary and then define support. We are going to select the spring, point spring support. Then we are going to use the compression only spring. So this is the place we are going to input the stiffness, and the stiffness should be in DZ minus. When I was explaining where to apply the load, this is how to apply the load on the spring. I don't know if you remember. So I'm going to select the first node. I can put the number so you can see very well. I'm going to select the first node and the last one. They have the same value. That's why I select them like that. So the value of the stiffness we get is 4149.3. Then I have to click on apply. Then for number 2 and 12, they have also the same number. We have 9844.5 and apply. Number 3 and number 11 is not clear. Number 11, they have the same value. It's 11410.5 apply. Then number 5, 6, 7, 8, 9, they have the same value as the previous one. Then I can hit apply. But as you see that this structure, it has only vertical reaction, and all the reaction are parallel. So when the reaction are parallel, the structure is not, it's unstable. So to make it stable, we need to specify the other boundary condition here. We need to constrain one node here in X direction. We need to use the support, and then we constrain the first node in X direction, so the structure will be stable. So I select this first node and this value here, and then I hit. I constrain only this node in X direction, so the structure can be so we can get a good answer, not a singularity. So we have the boundary condition and all the load, so we can run the model by clicking on run here. So you can see that the problem, there's some problem that occurs. Let me check the result here. Okay, let me explain using these results here. After defining the load, we can run the analysis like this, and then we can check the result. So the total solution time is 14.5 seconds. So we can check the result in result tab, and then check the reaction. We can check FZ direction, and then we click on apply. So where the arrow is in red, it means the maximum. To check that value, you can click on value, and the software will show you the value. So to check the bending moment, because it's the most important, you click on force and then beam diagram, and then select MY. Then if you want to check the value, check value, deform, the deformed shape or the undeformed shape. Then you can click on apply. This is the bending moment related to the dead load. So let me delete the value. So because it's not clear, you can increase the scale factor to 5, then you can check the result very clearly. And if you want to check the value also, the value else they are too much, then you can check only the diagram like this. And about the water pressure in the horizontal direction, okay, you can check the beam, the bending moment diagram like that. So to define the load combination, you need to go to result, and then the load combination, you need to specify them like that. And then you go to concrete design, because I already defined the loading combination, so I can delete all of this. Then I can explain how I get this. You can click on the spreadsheet form to check the coefficient I use for the strength, the ultimate strength design. So for the dead load, I use 1.2. You need to input it manually here, 1.2, and for the live load, it's 1.6. And where we don't have any value, it's 0. And after inputting the value, as I showed you in that table in the PPT file, you need to copy those table and paste it in this table in Midas Civil. So after pasting this table, then it means that we have defined the load combination. So in order to have the design load combination, in Midas Civil provide another technique to make the addition of the load combination. You can go to load, and using load combination, you can click on this icon. Then you have the load that you define here. So after having this load here, you can select the load that you are going to add together. Okay, let me explain slowly so you can understand what I'm doing. before I told you that, okay, I can delete this result so I can explain very well. Before I told you that when you are applying the load on the spring, the compression spring, I told you that you need to be careful about the direction you are applying the load. So you need to go, when you go to, okay, if we want to check the load, can go to the work tree and check W. For this case here, we had load applied here for 13, 15 and 45. But when you make the design load here, you need to make sure that you don't have a minus sign when you have a big value, a negative value when you make the addition of the top and the bottom load for the buoyancy, as explained in the PPT file. So to avoid that mistake, you need to go to load and using load combination. Then you select the load you are going to make them in one condition like this. After selecting the load that you specify for the combination, then you can read this one, a load case and design combination name. So the design combination name, it's are going to start by N. As I did this before, I will show the result. If I click on apply, then this will be affected by N. The load combination affected by N means that is the addition of all the applied load. So let me show you those. When you click on apply, you can realize that for the NUSD, before we had only USD, ultimate strength design, but when we have N like that, it means that we have added all the load combination that we have. Let me go to the load combination, then I can show you result load combination, concrete design spreadsheet. So when I have this value like that, to make this combination as one load, that's the meaning of N. The N means for the design load, replacing using the factor that you use when you are specifying the load factor. So when you add all the load factor based on the direction of each load, then you can make the design very well. The other question, when you use this result like that, okay, let me go to the concrete design. You need also to specify the envelope, because we need to have the load that we are going to use in the design. So we need the envelope. For the envelope, it means that we are going to combine all the nodes together and make them as one envelope to look for the maximum bending moment. So to do that, you have to define another load here, another load combination starting by E. It means the envelope. Then we are going to check the strength in the for the design, and then we are going to select envelope. This one is for the case we have these 8 different loads here. The USD, one envelope for all the ultimate strength design, and then one envelope curve for the serviceability. So to check the diagram, you can go to the results, and then because I delete the solution, we need to run again in the model to have those curves. So after running, then I'm going to explain a little bit about the design is going to be faster. So to check those envelope, to show the maximum bending moment of the envelope, you go to results and then force beam diagram. Then you select the envelope load called CB combination all for USD, EN USD, and then you select the MY for the bending, and we can increase the scale factor to 5, and we can check the deform and undeformed shape and the legend. Then we can hit apply. So this is the The first curve here, it shows the maximum bending for all the load combination we did, and the minimum value for the bending is that. So you can check even the value like this, because there are a lot of values, so we can get rid of the value. So you can check the value, the maximum value. You can check the section when we have the big value at this corner of the back. So to have this shape, that's why we changed the global axis to the local z axis in order to get a good result like this. If you don't change the direction of the local axis, you will not get this shape. And this, as you can see, that is the good result to have when you're analyzing the box culvert in. So for the design, we go to design tab. Because I have a Korean version, it's MODS, but in the version, international version, it's written here design. So we are going to use Eurocode to make the design of the top slab and the wall of the box culvert. So I'm going to select here. There are other code you can select from here, but today I'm going to use Eurocode, and we are going to design the box culvert. So we select the design code as Eurocode. The national annex, we select Italy. The moment distribution factor is 1, and we are going to design the slab as singly reinforced beam. And for the column design, we are going to use this axial load plus biaxial bending. For the strut angle for the shear, we take 45 degree, and then we click apply. Then we continue specifying the parameter. Then for the safety factor for the material, if you want to update by using the code, you can click here. Then this value can be updated according to the code. But if you don't want to update, you just leave the way they are, and then you click OK. So if we can continue, we can modify concrete material. So when we say modify, you have to select the material and specify the code that you are going to use for the material, the strength, the compression strength you are going to use, and then the rebar code you are going to select from. I use ENRC, it's one of the Eurocode too. I select the rebar having 500 MPa, and the sub rebar also I select the same value, but you have to change this value when you are doing your design for the sub rebar if you want. And the unit I have, it's kilonewton mm square. You can change that value whenever you want, sorry. And then you click modify. Then after you click modify, then you can close the tab. Then after modifying the material, you go to limiting rebar ratio. You go to limiting rebar ratio. You have to design the column and the brace design like this. You can place this at 0.04 for the column, and for the bracing, because we don't have any bracing, so you don't need to put it like that. And this, if you have shell elements, then you can use also this element, but for now we don't have those elements in the model, so it means nothing. So for the serviceability parameter also, we need to specify the exposure class. In Eurocode, there are a lot of cases for the exposure class, so you need to select the exposure that fits with your model, and then you select the stress parameter K1, K2, K3, K4. But as we don't have a lot of time, we use just the default value, and then you have to specify the crack control, how you are going to control the crack of the concrete. Then you can specify also the deflection, because the permanent deflection control. So I use the default value. So you need first to select the slab, the beam you are going to check. Then you are going to hit on apply in order to apply this value for the beam element. Then you click apply. After clicking apply, then you go to beam section data for design, so you can design the beam. So you need to select the section, and then you specify the value of the stirrup data, and then the number you are going to use. And these are the concrete cover. You can check this picture, then you can specify the concrete cover from the top, and this one is a concrete cover from the bottom. So after specifying this data, you can go also to the upper slab using, well, I use the same data for upper and lower slab. After specifying this data, then you click on add and replace, then you close. When you specify those data, then you go to concrete design, concrete code design, then you click on beam design. Then the software will design all the beam for the upper slab and the bottom slab. So as you can see that all the member and the section is passed, you can check the detail, the graphic report and the detail report here by clicking on. If I click on, I need first to select the section and click on graphic. Then in the graphic detail, the graphic report, you are going to see the amount of the reinforcement you can use in the design for your section, the bending moment capacity, and the shear capacity. For the detail report, then you can have the software open directly Microsoft Word when you click on the report. Let me show you Microsoft. I don't know if you, when I click on the detail report, so the software give me the detail report, the calculation, all the calculation I did for the design, and you have all the parameters you need in the design. This is how you can generate the reports in Midas Civil easily. So we can go again to Midas Civil. So when you click on detail here, the software open directly the file for Microsoft Word to generate the report. For the column, it's the same procedure. It's not that difficult. You go for design, and then you have to specify all the first step that we do, the first, second, third, and fourth. Then you go to column section data for design. You have to specify the data for column. So there's the software, when you have a vertical member, the software consider it as a column. That's why it consider the wall of the culvert as column. So for the horizontal member, the software consider them as a beam. So that's why when we design beam, it selects only the horizontal section we have for the beam element we have in horizontal direction. So these are the data used to design the wall of the culvert. We have the concrete cover of 85 mm, and the ties, I define them as a D2032, and their number is 20. After defining this parameter, then I hit on add and replace, and then I close the window, and then I go to concrete code design, and then I click column design. Okay, so you can see that all the member also they are passed. To check if there are some NG, you can select here. So you can see there's no NG in the design. All the section is passed. So to check the graphic report, you click on graphic, and then they give you the PM interaction diagram. Also can check it, their value here, and the shear force resistance check. So this is how you can check the different reports. Even for column, if you hit on detail, so the software will bring you to Microsoft Word having all the detail of the design you need. I didn't show you the shear result. The shear result also you can see it in result force, and then go to beam. Then you can select FZ. Then you hit on that. Then you can see the shear for the maximum shear and the minimum shear of the envelope, the max and the minimum of the shear. You see that we have two lines for the first line is for the maximum, and the second one is for the minimum shear. So I don't know if we can have some question. I can open the mic. I can see Mr. Peter Okitoi. I don't know if you can speak. I can see also Engineer Nathan Mboichana.
Yeah, it's Nathan. Can I speak?
Okay, I can hear you.
Yeah, like I have like one question so far.
Okay.
Is there a way to automatically disperse the traffic load through the fill in the Midas?
Yeah, I didn't use
Because
that option about the moving load because I'm preparing another webinar that we are going to use the moving load in okay, let me show you where we have those application about the moving load in Midas. So you see in load menu,
yes, okay.
you have moving load here.
Hold on. Is it my net? Okay, I'm seeing you. Is your cursor at the meshed design?
Yeah,
okay.
Yeah, when you select moving load here, you need to specify the code you are going to use for the track you are going to use on the structure.
Okay.
So when you select the code, I can select Ashto code, for example. Then when you select the code like this, then you can specify the traffic line lane. Sorry?
Kindly, if I'm to cut you short, like on my side, the screen is not changing at all. Like maybe I'm having a lag in the screen movement. I'm still on column section data for design.
You don't see my screen? My screen is
I see your screen, but it's stuck at column section data for design.
Really, those window are closed them. I don't have any window for design right now because I closed every window for the design detail.
Yeah, maybe you proceed. I'll check it out in the recording in case the recording will be up to date with the screen, but I can listen to you. You can proceed.
Okay, let me check if it's Midas Civil. Hello.
It could be a network issue, maybe on my side, because I'm stuck on column section data for design. It could be on my side, so maybe I'll refer to the recording.
Okay. When I finish the recording, then I will send you the video in the coming days after editing. So in the load menu, we have a moving load. I didn't use this because I'm going to prepare the other webinar relating on the moving load on Culvert Bridge. But the way I use the moving load, it's the simplest way to use them. But in Midas Civil, we have this moving load application, and that we can define the lanes and the traffic surface lanes depending on the elements you use in the model. So when you use the frame or the beam element, you have to specify the traffic line lane using this the traffic line lane function here. But when you use plate element, you need to specify the lanes using the traffic surface lanes. And after specifying this, depending on the elements you use in your model, then you can specify the vehicle. And for the vehicle, you can select the standard vehicle or you can add the user-defined vehicle. So for this, for the moving load information, I'm going to make another webinar only for moving load and seismic design of RC culverts in the coming months. I don't know if another person has another question.
Kindly, if I may add on that, just kindly.
Oh,
one last more point. Yeah, I think you did get me well. Like my point of concern of the moving load was on the dispersion of the load. Maybe in another webinar, you're going to enlighten on that, on the dispersion of the load. Thank you.
Okay, I will prepare the webinar explaining all about the moving load in Midas Civil and the influence line, how you can visualize them using Midas Civil. It's possible to check all the data related on the moving load in Midas Civil. Another question, please.
Hello, hi.
Hello.
Yes, so I only have one question. Is it possible for us to get a recording of this webinar for maybe future review? I understand maybe this could have been discussed. There was a moment that I had to, because I am actually a civil engineer on site, so there was a moment that I had to be disconnected from this webinar to attend to site issues. So I was
Okay.
curious, is it possible for us to get a recording of the webinar? Thank you.
Yes, it's possible. So from tomorrow, I'm going to edit the video, and after editing, I will send the video to you.
All right,
Can
thanks.
I get your name? Can I get your name?
Sure. Should I maybe send it via the question board of this app, or maybe I just send it to you via LinkedIn? Which is easier?
Okay, you can use my email then. My email.
Okay. Can I have it?
You have my email, right?
Technically, I don't. I only have your LinkedIn. Maybe would that be convenient?
Okay. You can send me a message on LinkedIn. Okay.
Okay. All right. Thank you.
Thank you. Okay. Thank you. So if the other people have any question, please ask the question. And for your information, I can say that for those who has participated in this webinar, if they want to have the products of Midas Civil, they can have the discounts of 30%. So for those who want to use Midas Civil and want more training, they can have discount price if they buy the software. Okay, if there is no another question, then I can say that thank you for your attendance, and I hope that we are going to make another session in the coming months about the moving load in Midas Civil, so you can learn a little bit more about designing the bridge using Midas Civil. So for sure, you don't have any other question related to training, because I think that you want to know more about Midas Civil. Is there someone who wants to be trained using this software? So thank you and see you next time. I'm going to communicate with you by email, and I can call you also, as I have your phone numbers here. Is there any question?
No, there's no question.
Okay, thank you for attendance. So I will call you and send you emails in the coming days. Thank you very much.
Okay,
Thank
thank
you
you.
too. Thank you.
Thank you very much. See you next time.
Okay.